we've set f of x equal to 0 and solved for the 0, made the interval, split it up because there's a 0 in that interval, and then that lets us split up the integral into two separate integrals, and then whatever the integrals are, we take the absolute value of them. Okay, so that's step 2 done. Now we just take each separate integral, and that will give us, well, what will that give us? I'm actually going to write this out as it will be, and then let's actually solve for the different things. So, because remember, we're going to want f of 0, capital F, that is, capital F of 0, capital F of 3/2, and capital F of 3. And here's why, because this is going to be the absolute value of f of 3/2 minus f of 0 plus the absolute value of f of 3 minus f of 3/2. Okay, so if we know what this is, we don't have to calculate it twice. Does that make sense? So well, first we have to calculate what is the actual antiderivative of 2x minus 3. So let's do that. Capital F of x, the antiderivative of 2x minus 3 is, well, the x is to the power of 1 here, so we raise it to 2 and then divide it by 2. Or you can think of it as what function gives you a derivative of 2x? It's x squared. And then 3 is a constant, so it was just 3x to begin with, 3x to the 1. And then when we take the derivative of that, we just get back to negative 3. Okay, so this is the antiderivative. And now we just need to plug these things in. This one is nice. This is equal to 0. And let's do this one next. This one is equal to 9 minus 9. Oh, great. That's also 0. This one is a tricky one, though. So let's do that. 3/2 squared minus 3 times 3/2. Well, that's 9 over 4 minus 9 over 2. So sneaky fractions. We need to actually multiply this by 2. So this is 9 minus 18 all over 4. In other words, negative, I'll put that here, negative 9/4. Okay, any questions so far? Is this all making relative sense?
Yeah, so far so good.
Okay, so now the reason why this might be a good step to write out, because it tells you which piece goes where, and there are fewer negative signs to worry about. That's also the reason why I'm having you do absolute value of everything, because then you don't have to worry about, well, do I put a negative in front of here, or do I put a negative in front of here? You don't. You just don't worry about it. You just put the absolute values around each one. Okay, so what this is the absolute value of negative 9/4 minus 0 plus 0 minus negative 9/4. In other words, positive 9/4, right? Take the absolute value. This is just 0. The positive version of this is not positive 9/4. And then this one becomes positive anyway, but then the absolute value ensures it's positive as well. And then there's 9/4 there. And so what you get is 18/4, in other words, 9/2. And you can also see from this, well, the area from 0 to 3/2 is actually, from 0 to 3/2 is negative 9/4. And then from 3/2 to 3, it's positive 9/4. And so that's why if we go just from 0 to 3, you get 0 minus 0, which is just 0. But the actual total area involved, you have to take the absolute value of each part, and this is the easiest way to do that. Okay, so any questions about the process for this? I saw a few things that were a lot more complicated than this, so I'm curious as to whether this helped or not.
I think it makes sense.
But is it is it repeatable? I guess that's the question.
Uh-huh.
Okay. So yeah.
Yeah.
Question? Okay. All right. So, but yes, I do want you to figure out when it's equal to 0, that cuts up the interval. And then once you've cut up the interval, you can split up the integral, and then from there you calculate each one. But you can make a chart to make it a little bit faster as you're plugging things in. So you don't have to do it multiple times in multiple places. But let's which of the other three were the most confusing? Do that one next.
Definitely 18.
18? Okay. All right, so let's do 18. Okay, so for 18, you have the integral from 0 to 4 of the absolute value of x squared minus 4x plus 3 dx. Okay, so the first step is what? What's our first step in solving this?
Well, factor it.
Factor it, right? So when is the function? Yep.
Times x minus 1.
Yes, perfect. Okay, so what this is equal to 0 when x equals 3 or 1. Okay, so then let's draw out the interval. We're going from 0 to 4. And we have to stop along the way at 1 and 3 because that's where the function actually hits 0. So it could change from positive to negative and then maybe stay negative or something, or change to positive something after that. But in that region, this is all going to be one thing. So if we take the absolute value of each region, we'll just get the total area. So okay, so that tells us how to split up the integral, and that how we're going to split it up. We have to have one for this one for this one, and one for this one.
So the integral of 0 to 1, from 0 to 1 of the function.
Yep.
Plus the integral from 1 to 3 of the function, plus the integral of 3 to 4 of the function.
Yeah. Okay, that's exactly right. So we need each of these three, and then we're going to just put them inside absolute value things once we know what they are. And the antiderivative, it's all the same functions. The antiderivative is going to be the same for each one. And I think I saw somebody doing finding when f of x is greater than 0 and when f of x is less than 0 and getting intervals and doing that. That's great. That's exactly what we would be doing. This is just a simpler version of that. But yes, you could find all the regions where this is negative, and then just maybe let's say it's here and here, and then just put a minus sign in front of each of those. No absolute values, just put minus signs out front. That also works. But for the way that we're going to do this, let's just stick to one method. So so we are now going to calculate all these. So first we need what is capital F of x equal to. So this was, here was the function inside here. That's this with no absolute value. What is the antiderivative of this function here? Questions? All right, so x squared becomes x cubed over 3, right? Minus, what does this become?
Negative 2x squared.
Yes. Plus 3x. Okay. So this is the antiderivative of the function. And then let's plug in the different values. So we have 0, 1, 3, and 4. Now, again, you don't have to do this part, but what you're going to be doing in the next step is putting all these values in. So it can help to just to know what these are, so you can put them in directly, but just to remind ourselves exactly what the integral from 0 to 1 means, we are putting in capital F of 1 minus capital F of 0, because you always put the top one in first. And then we have capital F of 3 minus capital F of 1, and then capital F of 4 minus capital F of 3. And so we need to know what all these are. So if you plug in 0, you're going to get 0. If you plug in 1, what do you get? 1/3 minus 2 plus 3. In other words, this is positive 1 plus 1/3, so in other words, 4/3. Okay. And then if you plug in 3, well, you'll get 27 over 3, in other words, 9, minus, well, this is 9 times 2, so 18, plus 3 times 3 is 9. So you have 9 plus 9, which is 18, minus 18, which is also 0. Well, that makes this a lot easier, doesn't it? And then f of 4, if you plug in 4, you get 64 over 3. Minus 4 squared is 16 times 2 is 32. I believe, yeah, that's right. Okay,
Yeah.
plus 3 times 4 is 12. So plus 12. Okay, so what we're really subtracting is 20 from this. And 20 is 60 over 3. So we have 64 over 3 minus 60 over 3. This is very, very sloppy handwriting. I'm just trying to fit it all in. So in other words, this is also 4/3. Well, that's odd. Okay, so both 1 and 4 are 4/3. The other two are 0. So let's put in the zeros first. Okay, so if you have f of 0, that's 0. And f of 3 is 0. And f of 3 is 0 over here. Okay, and then the other ones are 4/3. 4/3. 4/3. Okay, so then you have positive 4/3 plus 4/3 plus 4/3. In other words, you just have the number 4. Yikes. Okay, so questions about that one? Did that help make a little bit more sense about what the whole process is?
Yes, that was much better.
Okay, good. So yeah, similarly for 16, once you split it up and have just the 3 and then the absolute value of x minus 4, then the 3 part is just its own thing. that's just a regular definite integral of a function in 3. The one with absolute value is now much simpler. It's just x minus 4. And you just do the same process. You solve for when it's 0, make up an interval, split up the interval for just that one, and do the antiderivative and plug it in. I guess, yeah. I think everybody's turned that assignment in, right? I believe so. Regardless, I wanted to kind of cut it down to just 2 problems anyway, so we did 15 and 18 together. So if you haven't done it, you kind of only have 2 problems to do. Let's see though. I guess I'll save the other thing I was going to talk about for tomorrow, but just as a sort of a preview. This idea goes on to chapter 5 very, very easily. Once you know how to do this process, then you can very easily do right where you're finding when the function is 0, and then when the thing below it, when it's below 0, you take the absolute value and so on. This whole process works very easily with something like the area between 2 functions. So let's say you have 2 functions and you're trying to find the area between them. This is almost exactly the same. It looks very different. But tomorrow we'll talk about how this actually is almost exactly the same process. So yeah, we're gonna that's what we're gonna talk about tomorrow. Because notice how we can actually, if we're adding the 2 functions, or well, words. I think I'm done actually recording.